an optimization problem with one equality restriction using Excel. Here is the problem. Find the minimum of that function subject to x squared plus y squared equals to 10. That's the circle of center 0, 0 and radius 10. Sorry, x squared plus y squared equals to 100. So let's call Excel. What do we need? We need two variables, x and y. We need here our restriction, and we need the function. So let's write everything. The variables x and y we want to find, we don't know how much. The values of these functions, so we'll put just some initial value, 0 and 0. Our restriction is, so that's a formula. So we put equals to, what should be x squared plus y, which is here, squared. Don't put equals to anything here. Now we want this to be equal to 100. Our function, we write here the function, equals to parenthesis x, so we go here, minus 20 squared, plus parenthesis y, so we move here. Observe we're moving where the variable is, not where the letter y is written, but where we have stored the variable. 15 squared. That's our function. That's it. Okay, so now we go to data. In the Mac, in the Windows is slightly different, but anyway, go to solver. And what do we want? We want to objective. That's the cell where we want to, the final result is here. So we mark this in here, this cell. Okay. And here is the cells where the variables are. So we click here and we mark this one, press the shift, this one, fine. Now, what do we want? In this case, we want the minimum. And we add, here is the constraint, so we add one constraint. Let's see. The reference should be where the formula is, in this case, is here. And now we want it to be equals to, and what do we want equal to? So we put this thing here. Doing it in this way, rather than writing 100 here, gives us the freedom to change this value later if we want. Add. Sorry, add no. Okay, this okay. Should be okay. Cancel this one. Okay, instead of add, you say okay. Make unconstrained variables non-negative. We don't need that. Solve. Let's see what Excel does. You wait for a little bit, and it's trying a few things. See, the values are changing a little bit till it gets to the solution. I say keep solver solutions. Okay, so solution is 8 and 6. Okay, because a squared is 64, 6 squared is 36, so together it's 100. Not exactly, but it's quite approximate. And the function is at 225. Let's look at this with GeoGebra. Here in GeoGebra, we put our circle and the level curves of our function. The level curves keep increasing, so the first one touching the circle will be the minimum. And according to Excel, should be at 225. Let's see, let's go to the value of this value of D, 209. Let's move to 225, and what do we have? 225, 24, 25. There, you can see they are touching, and this is the point. The point here is 8, 6, exactly. So the solution of Excel is very approximate, but one can just check that it's actually 8, 6.